Most people associate creatine with young men lifting weights in gyms, chasing marginal gains in athletic performance. That framing has obscured what is becoming an increasingly interesting story in the science of healthy aging, one that connects dietary meat intake, muscle mass preservation, and cognitive function through a single biochemical compound that the aging body becomes progressively less capable of producing on its own. Creatine is synthesized in the liver and kidneys from the amino acids glycine and arginine, and it serves as a rapid phosphate energy buffer in tissues with high and fluctuating energy demands, primarily skeletal muscle and the brain. The body can produce roughly 1 gram per day through endogenous synthesis, but the average omnivore diet contributes another 1 to 2 grams daily from red meat, pork, and fish. Vegetarians and vegans, who rely entirely on endogenous synthesis, consistently show muscle creatine stores that are 15 to 20% lower than omnivores. This matters more than it might initially seem. Sarcopenia, the age-related loss of muscle mass and strength, is one of the strongest predictors of functional decline, hospitalization, and mortality in older adults. It is not simply a cosmetic concern. Maintaining muscle mass is directly linked to metabolic health, fall prevention, immune function, and the ability to recover from illness or injury. Research indicates that higher dietary creatine intake from meat is associated with better muscle mass preservation in aging populations, independent of total protein intake. The mechanism appears to involve creatine's role in energy availability during resistance exercise and its influence on muscle protein synthesis signaling pathways. The cognitive angle is newer but compelling. The brain accounts for roughly 20% of the body's total energy expenditure at rest, and creatine is a meaningful contributor to cerebral energy metabolism. Studies examining vegetarians given creatine supplementation have shown improvements in working memory and processing speed, findings that suggest the naturally lower creatine stores in non-meat eaters translate into detectable cognitive differences. In older adults, some trials of creatine supplementation have shown benefits in memory tasks, which is consistent with the known role of creatine in maintaining ADP availability during cognitively demanding tasks. It is worth being direct about one concern that circulates persistently: the idea that creatine supplementation is harmful to the kidneys. In people with healthy kidney function, this claim is not supported by the research literature. Creatine does raise serum creatinine, a kidney filtration marker, but this is a direct consequence of increased muscle creatine stores, not a sign of kidney damage. Long-term supplementation studies have not found adverse renal effects in healthy individuals. That said, anyone with pre-existing kidney disease should consult a physician before supplementing, because in that population the situation is genuinely different. For older adults, particularly those who eat limited meat or who are dealing with declining appetite, creatine supplementation at 3 to 5 grams daily is one of the better supported nutritional interventions for muscle preservation available. Combining it with resistance training amplifies the benefit considerably. The aging muscle is anabolically resistant. It responds less robustly to protein feeding than younger muscle. Creatine appears to help shift that resistance in a more favorable direction, and that is a meaningful advantage in a population that needs all the help it can get.